P or S2P, whatever, near the source S1 or S2, whatever, then what will happen? Suppose if I put this thin sheet near the S1 source, then what will happen? The S1P or S1O, the light coming out from S1 will travel some part inside the thin sheet and some part in the air. But in case of S2 source, it will travel throughout the path in air. Although they have equal geometrical path difference, but optical path will be different because some part of the light will go through the thin sheet of refractive index N. Okay, so now what I have to do, I have to put one sheet here near the S1, let's say. So if I put it, then what will happen actually? So let's do the same experiment by putting so let's say it is S1, let's say it is S2. Now we have put one thin sheet of thickness T and refractive index N near the source S1. Then what will happen? So let's just consider the central fringe. So in that case, geometrical distance S1O and S2O, they are equal. Okay, but since some part of the light will travel through the thickness T, then what will happen? The central fringe, which was supposed to stay here, now they will move at some point here. Okay, the central fringe will move to some places O to O dot. Okay, because now the S1 optical path S2O is not equal to S1O, but S2O dot equals to S1O dot. So now what will happen? Since the central fringe will shift from O to O dot, okay, this distance, then the whole fringe system will shift towards the upside. Okay, if I do the same thing with S2, then what will happen? The total path in the S2 side will increase. Then the fringe system will, central fringe will move to O dot. Then the whole fringe system will shift downward. So that is called displacement of fringes. So now if I calculate how much the displacement of the fringe actually happened, from that we can calculate the thickness of the thin film you have inserted in, or what may be the refractive index of the thin film you have inserted in the experiment. Okay, now what will happen then? It will also change to P dot. Let's say so, like this. So now what we are doing, so we have to calculate how much. So if previously P was here, then these two will be same. O dot will be P dot, because the whole fringe system will displace by the same amount. So that's why actually we are saying the displacement of the fringe system, maybe the whole system, not a single central fringe or P is shifting altogether, but they are altogether they will shift all the fringe system together. Okay, so now we have to calculate how much actually that this shift actually happened due to the insertion of this thin sheet near the source S1. Okay, that we will calculate. Okay, now what is T? So this is the same experiment. So okay, so now what we have to do? So we have to calculate what is O dot. So that is actually displacement of fringes. Displacement of fringe pattern. The whole fringe pattern will shift in from O to O dot. Okay, now we have to calculate this one. So now what is this? This thickness of the sheet is T and the refractive index is, let's say it is A. Okay, so T is the thickness of that. So it has to be transparent, otherwise it will not work. Thickness of the transparent sheet. Transparent sheet like glass or mica, whatever. And A is the refractive index of the sheet, the same sheet. Okay, now from the definition of refractive index, we know that this is actually the velocity of, sorry, I made a mistake. Velocity of the light in air, which is c, divided by velocity of the light in the medium. So that is what we know. So now we have to find out the time required to reach the light from S1 to, let's say, P or P dot or O, whatever, they're same. So we can do it. So time required to reach light wave from S1 to P कितना होगा बताइए. So first of all, ये जो distance है, P distance जो है, that actually will actually go through the film of refractive index N, and let's say total path is your S1P. Okay, so now we subtract the film thickness T. So that is the path the light will actually travel through air. So now how much distance it will take? You have to divide by the velocity of light in air. So similarly, in T thickness, the light was traveling through the film whose refractive index is A. So you have, and velocity is V. So this is the total time it will take to reach the light wave from S1 to P. Okay, so now we can calculate it. So S1P minus T divided by C plus, so now ये V का मतलब क्या है? We can calculate 1 by V equal to C by N. So now we can calculate.
Can you repeat again S1P minus T by C? I didn't understand, get it.
Okay, so I am trying to calculate the light coming out from the S1 source, how much time it will take to reach P or P dot, whatever. Okay, let's say P, how much it will take time. Total path is how much? S1P. Okay, so now within S1P, the T is actually distance in which the T distance light will travel through the film. So that means how much time it will take to cross the film. So T distance divided by velocity of the light in the medium V, in the medium of refractive index N. Okay, so now, or how much path is left? So S1P minus T is left, which is in the air. So this is air.
Yes, sir.
Path, and this is your film path. So now how much time it will take to cover the air path? So divided by the velocity of light in air. How much time it will take to cover the film path? So T divided by the velocity of the light in the film V. That's what I'm doing. So CT by N. So that means it will give you how much? हम अगर calculate इसको ये लेंगे तो 1 by C लेंगे, तो it will give you S1P minus, अगर, so it will become T plus CT. Okay. Did I make a
Sir,
mistake?
once n by c, sir.
Acha, acha. That's what n by c. It will become n by c. So it will become nt. So that means ये कितना होगा 1 by c into h1p minus, if I take how much increase it's happened, so how much it will become n minus 1 into t. So now you see the previously before the insertion before inserting the thin film in the S1 nearby the S1 source, what will be the time to reach the light from S1 to P? तो जियोमेट्रिकल डिस्टेंस कितना था S1P पहले था और पूरा ये एयर था. So now if I divide by the velocity in air, so it will become S1P. Now this much is the increased time, है कि नहीं? पहले अगर यहाँ पे ये नहीं होता तो पाथ कितना होता? जियोमेट्रिकल पाथ S1P वो पूरा एयर में जाता. एयर का वेलोसिटी कितना c है. So this is the time it would have been taken before inserting the thin film. Okay, so now after inserting, what happened? This much path length is increased. Okay, so this is the increase of optical path due to this is the increase of effective optical path due to the thin sheet. पहले जब thin sheet नहीं था तो पाथ कितना था? S1P था. Okay, so this is now previously ये S1O equals to S2O था. Okay, before inserting, so that means before inserting it was S1O equal to S2. Now it is not because the path difference S1O optical path is now changed by n minus 1 into t. So that means now S2O minus S1O is not 0. So that means the central fringe here it will not occur yet. So what will happen? So this much will change the position of the central fringe, and that is actually your displacement of the fringe. Now we can do it very easily. So now बताइए, so now अभी क्या था? पहले S1O equals to S2O. This was before thin sheet. Before insertion of the thin sheet. Now after insertion of the thin sheet, what happened? The central fringe is moved from here to here. So that means now it becomes S1 dot तो था ही, उसके साथ इतना ऑप्टिकल पाथ इंक्रीज हुआ है. So n minus 1 equals to S2. This is the new condition for having the central fringe. So after thin sheet insert. Okay, so now I can calculate it. That means ये पहले S2 minus S1 O equal to 0 था, जो आपको central fringe दे रहा था. Okay, so now ये क्या होगा आपको? S2O dot minus S1 O dot equal to n minus 1 into t. So this is the condition for central fringe. So now कुछ देर पहले हम लोगों ने प्रूव किया था तो कुछ दिन पहले हम लोग प्रूव किए थे कि ओपी yn इक्वल्स टू क्या था, this is some order, the zeroth order of central fringe, so that means कुछ देर पहले हम लोग प्रूव किए थे, so yn ने क्या था ये, कुछ देर पहले हम लोग प्रूव किए थे डेल्टा इक्वल टू s2p माइनस s1p इक्वल्स टू क्या था, d by d into yn. Yn means the distance of the fringe pattern, okay, from the central fringe, okay. So now in this case yn will become, so ये equivalent अगर हम लोग ये प्रूव कर सकते हैं, ये तो आपका p point के लिए है. So now if I do it for o dot points, so this is for any arbitrary point p. So now I can write the same equation for arbitrary point o dot. तो कितना होगा बताइए, s2 o dot minus s1 o dot will become कितना होगा, d by d o dot. So this is for any arbitrary point o dot. Okay, so now I can compare this equation and this equation to get the value of o dot, which is actually our purpose. Okay, so now I can compare these two equations. How much it will become if I compare these two? N minus 1t equals to d by d into o dot. So now we can calculate o dot equals to d into n minus 1 into t divided by small d. So this is the displacement of central fringe बोलिए और total fringe system बोलिए, बात सेम ही है. Displacement of central fringe or the fringe pattern okay. So now by experiment you can calculate this one o dot. तो पहले experiment किया without the thin sheet, find out what is the position of the central fringe. Now you insert a thin sheet in one of the source, then you see where is the central fringe now at present, find out the difference. So this difference is this one. So this is, you can find out experimentally. So this is also known experimentally, what is the distance between the slit and the screen, what is the distance between two slits, you can know. So now if I know the thickness of the thin film, you can find out the refractive index, or if you know the refractive index, you can find out the thin film thickness. Okay, so this is how we can use the Young double slit experiment to find out either the refractive index of the known thickness film, or you can find out the thickness of known refractive index film. Okay, suppose if you insert an unknown glass sheet thickness, you don't know what is the thickness of the glass slit, you just insert one in one of the way of the source, then you measure the o dot, so you know now n, which is 1.5, and everything is known, you can find out t. So by using this thing, you can calculate whatever I said, the thickness or the refractive index. So based on this experiment, you can have some numerical. I will prepare. So we have numerical. Based on this formula, you can have Okay, we will do this later. So, any question about this? Hello?
No, sir.
No, sir.
No, sir.
समझ
No,
में
sir.
आ गया?
No, sir.
तो यंग डबल स्लिट एक्सपेरिमेंट खत्म हो गया. Now we will move to the next topic, the thin film interference. So, as I said that it is very difficult to produce a pair of coherent source out of two independent sources. So that's why what you have to do, you have to take a single source and you split it in two. So what are the method of splitting sources? One is division of wavefront. So physically you can divide the wavefront by the like the double slit experiment. You can also divide the wavefront virtually. That is an example of Fresnel biprism experiment. And now the second is you can you use the division of amplitude to divide the to split up one source in two or many. Okay, so now second is actually division of, तो पहला था division of amplitude. Now you have a division of wavefront था. Now you have division of amplitude. Okay, so now division of amplitude मतलब है, suppose you have two medium. Okay, so let's say it is mu1 is air, and let's say this is glass, and let's say mu2, again you have mu1, it is air. Okay, so now if I calculate, if I put one source here, suppose a source, let's say it's a monochromatic source, so light will come here. So we know that you have to apply the law of reflection. So light will reflect from here, okay, and then some part of the light will refract. So since it's a denser medium, so it will come closer to the perpendicular, and then you will have another reflection here, and then you have another reflection here, like that. So similarly, you will suffer one reflection here, and then here, then you can have okay, again you will have one refraction here, refraction here. Okay, so it will go on like this. Okay, so now 1, 2, 3, similarly 1 dot, 2 dot. So now see, you have one source, okay, and this source can produce 1, 2, 3 infinite number of light sources like this. So now if you put one screen here, so these rays 1, 2, 3 or go on, they will interfere each other and produce an interference pattern here. So this will produce interference pattern. So for reflected rays, interference pattern for reflected rays. Similarly, you can also have interference pattern
Refracted.
refracted rays also. Refracted rays also. So now there is a catch. Why we are saying that is a division of amplitude? So now, so there is a thing called reflection coefficient. Reflection coefficient or transmittance coefficient, does not matter. So now we have what I've said, that this is mu1, this is mu2, and again this is mu1. So let's say this is 1, this is 1.5 glass, and this is, let's say, again air. Okay, so reflection coefficient R you can define as mu1 minus mu2. So now actually it's better to write difference. So it depends on actually the how much their refractive index actually the discontinuous change in the in the refractive index is happening in the boundary, that will give you how much light, percentage of light will reflect and how much percentage of light will refract, okay, in the denser medium. So now if I put this one, so let's say mu2 is your 1.5 minus 1 divided by 1.5 plus 1, which is actually your 0.5 divided by 2.5 whole square. So that will give you, I think, 0.04. So that means reflection coefficient 0.04 means, so that means only 4% of light will reflect. So that means, so 4% will reflect here. Okay. So if I say this is 100% of light which is actually incident on this point, so 96% will actually refract, and 94% will reflect. So again what will happen? So 94 ka 4% will reflect here again, because reflected. So 94 का 4% कितना होगा? 96 का, so how much? कितना होगा?
3.84.
3.84. देखिए तो, so you have 3.84%. So again, so you have again transmission. So transmission will have 96%. So now 3.84 का 96% कितना है? How much? निकालिए तो कैलकुलेटर से. कितना हो रहा है? हेलो,
3.6.
3.6. So that means, so you will get 3.6% like that. So that is how we'll decrease. See, amplitude, the first one was 100, then 4%, then 3.6. In the same way, it will decrease like that. Maybe it will, I don't know, 3.2% or something like that. So now you see, reflected lights, they have actually division of amplitude, 4%, 3.6%, like 3. I don't know how much it will be. So in that way, you can have a division of amplitude. If I use this thin film system to observe interference pattern, so that is called.
So then how much will again it will refract of 3.6%?
ये 3.6% हो गया ना आपका. So now 3.84 का 94%, 96% will be sorry 3. ये कितना होगा? इसका 4% it will come down here. Okay, and then 4% का 96% will reflect here. Okay, sorry, 4% will reflect here, and then 96% will refract here. So it will maybe very small. I think 0.1% or something.
Yes.
You can see that. So that is how the amplitude of the same light source can be divided up 4%, 3.6%, or similarly here also you can calculate. So 96%, okay, so 96% का 96% will refract here, okay. Similarly इसमें भी ऐसे ही होगा 3.8 नीचे आएगा फिर उसका 96% रिफ्लेक्ट होगा. So that is how we can observe the interference pattern by division of amplitude. समझ में आ रहा है? What is the meaning of division of amplitude? Okay. Okay, let's move. There is another phenomena. It's called Stokes law. So now, when you have a reflection, okay, from rarer to denser medium, then you will have extra phase change here. That is phi change. So now, what are the suppose in this point, so we have a reflection from rarer to denser medium. So you will have a phase change pi here. So here you have also reflection, but it is from denser to rarer. So there will be no pi change here. Here, denser to rarer, no phase change. So here only, if I calculate the path difference between 1 and 2, the geometrical path difference to hai because this 2 will travel extra this one and this one. Okay, and then extra pi phase difference will also be added in the one because it suffers extra path difference due to the reflection from the denser medium. Okay, we can prove it very vaguely that if you can suffer if a incident light suffer a refraction from a denser medium, you will have phase change. Pi phase change means just out of phase it will become. Otherwise it will become negative. We can prove it. So
Sir, one doubt.
eh?
Sir, one doubt. पूछना था. Sir, here 4% is reflection and 96% refraction.
Yes.
सर तो ये जो 3.8% जो निकाले इसमें कितना परसेंट रिफ्लेक्शन करेगा?
वही तो मैं कह रहा हूँ. रिफ्लेक्स मतलब रिफ्लेक्शन परसेंटेज है आपका 4% और लेट्स से ट्रांसमिशन परसेंटेज है 96%. Okay, that is how it gives you 100%, na?
Yes.
So you have a 100% light here, so 4% will reflect. So the intensity or amplitude of the one is 4%. Okay, so now
Yes.
so this is 96%. Okay,
Yes,
so
sir.
now if 96% suffer a reflection here, okay, so reflection में कितना परसेंट आएगा 4%, so the 96 into 4 divided by 100, so that will give you 3.84% up to here.
Yes.
Okay, now you have again transmittance. ये पूरा का आपको transmittance मतलब कितना है 96%.
56%.
So that will give you 3.6%.
Okay, sir.
Okay, again, so you have 3.8%. You have reflection here. So here you will get 3.84 into a 4% reflection hoga only. So up to here again you have a reflection here. So again you will have 4% of this one, and then you have again transmittance 96%. So that will give you. Okay.
Yes, sir.
So now the law says that, so if you have a change, reflection from denser medium cause extra pi phase change. फेज चेंज पाई मतलब है, और यू कैन से लैम्डा बाय 2 path difference. It will add. Okay, so this is called Stokes law. Stokes law. Now, so we can prove it very easily. Let's say you have a boundary here. Okay, so now if you have a light, suppose of, so let's say you have mu1, let's say have mu2. So if you know mu1, mu2, you can calculate the reflection and transmittance coefficient very easily, जैसे मैंने बताया. So now let's say you have a amplitude का एक light falls on this one. So now what will be the amplitude of the reflected light? So it will just, you have to multiply with the reflection coefficient. Okay, from 1 to 2, let's say it is A1. Okay, so again, so you will have one transmittance, refraction also, so which is kind of transmittance. Let's say it is A1. So there is a law, it's called reversibility of light. Okay, reversibility, principle of optical reversibility. That means if I put here and here two mirror, okay, so light should traverse the path already defined by the forward movement of the light waves. Okay, so that is called principle of optical reversibility. Principle of optical reversibility. That means if I just change the light path by placing mirror here and here, then it should traverse the old path already defined by the forward movement of the light. So if I do so, then what will happen? So this is your, so previously you have this one, and then this one, and then this one. So now what happens? So if you put here one mirror, if you put another mirror here, so your previously amplitude was AT1. So now what will happen? This AT1, suppose if I say that it is, so it is a boundary, mu1 and mu2, so it's also suffer a reflection here, obviously. So if I say that it has a reflection, then what will be the intensity? So originally it was AT1, now we have a reflection here, then you have to multiply with the reflection coefficient from 2 to 1. So this is the reflection coefficient. Previously it was A, and now it became R1. R1 is the reflection coefficient from light 1 to 2, and R2 is 2 to 1. Okay, very simple. And now we don't know that they are equal. Okay, we'll see that they are actually equal. So now what will happen? So now it is like this. So now the optical reversibility says that you can also retract this light. So if I do so, then what will happen? So it will suffer again one reflection. So A R1 तो था ही, again और एक बार आएगा R1 square. Okay? So now ये लाइन जो होगा ये भी सेम पाथ फॉलो करेगा. So ट्रांसमिट होगा. So let's say this is third one. So which AT1 and again it will have T2 because another transmittance it will have from 2 to 1. So that is what T2 2. So now, so this again AR1 will also transmit in this direction. Then what will be the intensity of this one? So it will become AR1 into, so 1 to 2 T1. Okay, so now see, originally we don't have any ray in this section. So that means if I prove that this optical reversibility is energy is conserved, so you cannot create any extra ray here. So that means principally this part should be 0 and this part altogether should be A. Okay, so from the conservation of energy, conservation of energy, you can write that A T1 R2 plus A R1 T1 equal to 0. This is one equation. And second equation you will get A R1 square plus A T1 T2 equals to A. Okay. So now in these two equations you can use to find out. Suppose if I take the equation 1, then what you will get? So you will get AT1 multiplied, so it will become R1, become R. Okay. And secondly, if I use these two equations, you will get T1 T2 equals to minus R1 square. Okay. So now, क्या T1 T2 equal to A है? No. A है. So T1 T2 plus R1 square equals to 1. So that means you will get T1 T2 equal to 1 minus R1 square. Okay, so now these are the two things we have got from optical reversibility. Okay, so now where we have a actual reflection of light from rarer to denser. Okay, actually we don't have any reflection here from denser to rarer because this is 0. Okay, so let's ignore this part, it's not implicating anything. But if I see this one carefully, that the reflection coefficient from 1 to 2 and reflection coefficient from 2 to 1, they are actually opposite. Opposite, this means they are actually out of phase. Negative means out of phase, okay? Which means that we have a phase change of, we have phase change pi. Okay? Pi phase change होगा तभी जाके आपको negative मिलेगा, out of phase तब होगा. So that is how we can prove that Stokes law, which says that if you have a reflection of a light from rarer to denser medium, that means it should strike on a denser medium. Okay, then you will have a change in the out of phase change in the reflection coefficient. That means you will have a pi phase change at that point. Okay, so this is called Stokes law. This Stokes law. ठीक है? आज का 11 ओके तो ये हम लोग मिला है नाउ वी विल मूव टू द एक्चुअल प्रॉब्लम ऑफ थिन फिल्म इंटरफेरेंस ये इसमें कोई क्वेश्चन है क्या हेलो
No, sir.
ओके वेरी गुड वेरी गुड
Sir, I have a doubt.
हाँ
Confused.
हाँ बोलिए बोलिए
सर स्टोक्स लॉ तभी अप्लाई होगा ना जब रेयर से डेंसर में रिफ्लेक्शन होगा
यस यस जैसे मिरर में होता है आप एयर में हो आपसे लाइट ग्लास में गिर रहा है सो ग्लास इज डेंसर देन ओनली यू विल हैव फेज चेंज ऑफ पाई अदरवाइज यू विल नॉट हैव
रिफ्लेक्टेड रे का फेस चेंज पाए हो जाएगा
पाई पाई
पाई
एक्स्ट्रा आएगा यस
ओके सर
आउट ऑफ फेज हो जाएगा मतलब आर माइनस आर हो जाएगा ठीक है मतलब अगर अगर R2 पॉजिटिव है देन R1 विल बिकम माइनस मतलब दे विल बिकम आउट ऑफ फेज ओके
यस सर
एक मिनट हाँ हेलो हाँ बोलो বলে দিলে আমরা বাড়ি যাচ্ছি আমরা যাচ্ছি শনি শুক্রবার দিন রাত্রেবেলা অজিত থাকবে হয়তো চলেও আসতে পারে ঠিক নেই পারমিতার দিন আসতে চাই আসবে নইলে আমি তো চলেই আসবো হ্যাঁ করতে হবে এটা। ছোট করেই করে দিই নাকি খাওয়া দাওয়া বাদ ছোট করেই হোক খাওয়া দাওয়া বাদ খাওয়া দাওয়া করে দিলে আবার মিক্স মিক্স হবে ফালতু হুম। 300-500 এরকম ছিল মনে হয়। হুম। হ্যাঁ হ্যাঁ ঠিক আছে আজকে কবে আমরা যাচ্ছি শুক্রবার দিন বিকেল বেলা খেয়ে দে হ্যাঁ 23 তারিখ আমি ভেবেছিলাম 3 তারিখে হবে কালকে বলতে অনেক তো ওরা থেকে যাবে ওরা আসবে না হয়তো গিয়ে আসার কোনো মানে হয় থাকো তোমরা বলে থাকুক ওরা কিছু যাবে যখন গাড়ি করে যাবো পালিয়ে আসবো টুকটুক করে হ্যাঁ ঠিক আছে চলো চানাচ তোলা যাক ওকে so so now the next topic is interference of reflected light so we will just consider that what will happen in case of reflected light so we will use parallel film parallel film there are two cases one is wedge film and parallel film wedge film means parallel film means like a glass slip the upper and lower surface of the film they are parallel okay and another is you know that wedge film though it must have some wedge kind of angle there are two things so first we'll discuss interference of reflected light in case of parallel film okay so it's very good thing to study so let's say we have a parallel film okay so let's say we have air, and we have some denser medium, and we have air outside. Okay, and let's say the thickness of the film is T. Okay, so now we will do the same thing here. So this is the perpendicular. So let's say light is incident one on the denser medium here. You have refraction here, and then in this point you suffer another reflection, and then you have reflection here. So I forgot to mention we have another reflection here. So we have one. So not only it will stop here, so it will go like this. Okay, infinite number of light will come out, and they will interfere to give you interference pattern. Now let's say this is your incident angle, and this is your again incident angle, and this is your refraction angle. Okay, so if it is so, this is also R, this is also R. Okay, so now we have to calculate. Let's say let's do the numbering. So this is the source. Let's say this is A point, this is C, this is D, let's say this is B, let's say this is E, and now another thing. So we have to find out the path difference. The path difference between ray 1 and 2. So that means the ray, these two will interfere. That means between AB and DE, we have to find out the path difference between these two rays. So now see. So if I draw a perpendicular here, let's say we have perpendicular, put a perpendicular here. Let's say this is L. Okay. Okay. ये ना नेक्स्ट क्लास का ये आ रहा है. अच्छा एक काम करते, टाइम हो गया.
सर
कॉल करते.
यस ओके सर.
Yes, sir. Okay, sir.
सर डबल स्लिट का न्यूमेरिकल प्रॉब्लम सर.
हाँ वो थोड़ा सा मुझे थोड़ा सा खत्म करके दीजिए. वी हैव वेरी बिग सिलेबस. लेट्स कंप्लीट द थ्योरी फर्स्ट.
सर इसका असाइनमेंट वगैरह कुछ नहीं है सर.
वो लड़का आएगा देगा मॉन्टेक. ठीक है.
ओके सर.